Hello everyone. Today we will continue to look at the content of HCIA-Storage. Today's main content is about the Intelligent Data Storage Disk Enclosure. Previously we introduced the controller enclosure, whose main function is naturally to control the overall data storage, serving as the main function. It's equivalent to its brain. As the name suggests, the disk enclosure primarily controls the hard drives. Here, first of course, besides the hard drives, it's not just about the hard drives. What else do we have in the disk enclosure besides the hard drives? There are also functions like power supply, cooling, cascading expansion, and so on. Here, we will mainly take a look at this. The overall structure of the disk enclosure. First, let's take a look at our disk enclosure. It seems to have some similarities with the control enclosures we've seen before, but it's not exactly the same. There are some parts that are quite similar. First, let's look at the left side. The left part is our hard drive module, and the middle part belongs to the system slot. This system slot is basically the same as the one inside the control enclosure we saw before. It's basically the same. At the back, there is the power module and our collector module. This side is also designed in a modular way, so whether it's the hard drive enclosure or the control enclosure, we use this modular design. The benefits of this, as mentioned before, are that no matter which part fails, it's very convenient to replace, and we don't need to shut down the system. You can simply plug and unplug directly here because we have this feature. The physical framework that carries our entire hard drive module and power saving module supports hot swapping. Overall, everything is plugged into this system chassis. Here, it's equivalent to us taking it apart to show everyone. Normally, inside the system chassis, we place our hard drive module and a power saving module. It's essentially a physical framework. As for the electromechanical module, it connects multiple hard drive enclosures through SAS or NVMe protocols, allowing for capacity expansion. Here, the range generally is mainly from about 25 to 100. This is our power saving module. As for the power module, there's no need to elaborate. It features a redundant design, supporting dual power supply, ensuring 99% availability. Finally, regarding the hard drive module, it supports a wide variety of types. It mainly supports SAS, and both mechanical drives and solid-state drives are compatible, so both types of drives can function normally. They can be supported normally and are directly compatible. This is the overall situation of our hard drive enclosure. Its main advantage is still our modular design. It allows us to perform quick maintenance easily. When a failure occurs, we can replace components online, ensuring our operations are uninterrupted, and allowing for flexible expansion. Our modular design enables horizontal expansion, meaning we can add many different additional hard drives. Add more hard drives. This is the overall form of our hard drive enclosure. After discussing the hard drive enclosure, let's take a look at This is the front view of the hard drive enclosure. So this is the front view of our hard drive enclosure. Previously, we also saw the front view of the control enclosure, right? This is the hard drive enclosures. Here you can see that we are currently displaying two types. Both are 2U. However, you can notice that the sizes seem a bit different. This side looks a bit larger, and this side looks a bit smaller, but that's not actually the case. It's actually like this. Here, it's because there are fewer slots, so the overall image appears larger. On this side, there are more slots. This side has 36, and this side has 25 slots. The number of teams is different. However, their overall size is actually the same. Both are 2U, so their height is actually the same. The height is the same, it's just that here, we have fewer hard drives. For this 2U, what we mainly support is... What is it mainly used for? It is primarily used for warm data storage. Generally, it uses more SAS structure SAS drives, with a single drive supporting up to 20 TB. That's 20 TB per drive. For the 36 drive setup, we typically use an NVMe drive enclosure, which is basically designed for all flash storage or solid-state drives capable of supporting microsecond level latency. It's worth it. Especially suitable for scenarios with high-frequency access. Whether it's high-frequency access, cold storage, or warm storage, it mainly depends on your actual business environment. If your server is primarily used for storage, access, If it's not accessed frequently or hardly accessed at all, and is just used for backup, unless there's a failure and we need to recover from this backup. In such cases, it generally falls under what we call cold data or warm data, and you can use mechanical drives. Our requirements for read and write are not very high. Now, if you are running some popular services, whether you are using a database, for example, if you are calling a database to retrieve data, there will often be read and write operations, including databases and other middleware services. In such cases, we mainly use NVMe or solid-state drives, flash storage, and so on. These are two types of our front view. As for the specific lights, most of them are quite similar. We have previously introduced the situation with the lights on the control panel. So let's take another look here. Over here is the hard drive bay, and this is the ID of the hard drive bay. The first one is the ID, and the second one, the blue one, right here in this position, is blue. You can directly look at the enlarged image because the picture here is a bit small. This blue light here, similar to Khalil Fong, is our hard drive location indicator light. When it blinks blue, it means it's locating, and when it's off, it means it's not locating. And then, the exclamation mark warning. As soon as you see this symbol, it means a warning. If it's yellow, it means there's an issue with the hard drive bay, there's an alert. If it's off, then it's normal. Off means normal. This is our alert indicator light, and then this is the power. The green one, this green one, is the power symbol. Just this one. This is the power indicator light for the hard drive bay. Green means our hard drive bay is powered on. If it's off, it means the hard drive bay is not powered on. The last one actually, whether it's in a storage server or any other ordinary server, it's actually the same. This symbol is actually very common. The power indicator light, when starting normally, you just press this button and it will start directly. This is one of ours. Front view, or frontal view, and then we'll look at what's next. Let's look at the back. The back looks like this, clearly showing the differences from the expansion and what we mentioned before. There are some differences in the controller and control box, right? It's not quite the same. Over there, the interfaces seem to be more, right? Here, the hard drive bay interfaces are slightly fewer. Let's take a look at the basic situation of the hard drive bay. Here we have numbered a total of 8, and we'll introduce them one by one. First, the first one is the serial port. The first one is the window. The second one, it's in this position. What is it? It's a mini version of SARS. Cascade port, mini SAS, Jillian port. The third one in this position. This is the ID display of our hard drive enclosure, which is actually the same as the one on the front panel. The numbers are the same. The fourth one here is our Jillian module. The fifth one is the power module. You can see there are two power modules for redundancy. And then the sixth one here is our onboard connection module. The seventh one is the onboard management port, and finally the power module. Here are also two capacitor symbols. These are two different models. The one above is a 2U SAS hard drive enclosure, and the one below is 2U. Pay attention to these two different models of hard drive enclosures. If you see the back, well, you might encounter them. There are two different appearances you can distinguish between them. This one is our SAS module, and over here is the NVMe module. This is a rear view of our hard drive enclosure. Overall, there are actually some differences compared to our previous control enclosure. The overall structure will have some sections, so pay attention when distinguishing them. First, you need to clearly identify what you're looking at. Based on the overall features at the back, you need to determine whether you're seeing a hard drive enclosure or a control enclosure. Otherwise, if you mistake it, you might misinterpret all the interfaces. This is the overall structure of our hard drive enclosure. So this is the overall design of our hard drive enclosure. It's actually similar to the control enclosure. The first thing it ensures is reliability, including easy expandability, which is our most basic requirement. Another point is the indicator lights, which you should pay close attention to if any issues arise. They will generally be directly displayed on the indicator lights. This is the overall content of our hard drive enclosure. If anyone wants to learn about RAID technology or wants to obtain RAID question banks, please send me a private message or leave a comment below the video for technical exchanges. Alright, let's stop here for today, everyone.